today. My name is Mike McKechnie. I'm an Azure Technology Specialist, basically an Azure architect. Have been with Microsoft for it'll be 8 years tomorrow, actually. I'm pretty sure. And so I'm here to talk today about if you haven't heard about AI in the past year or so, not quite sure where you've been. It's been around for a bit. It's kind of a big thing. But one of the things I found is coming from the developer world is, hey, it's really cool, and there's chatbots everywhere, and all that's awesome. But how do I take advantage of that AI capability in my applications, right? And that's where Microsoft has come up with something called Semantic Kernel as an easy way to integrate AI into your applications. So we're gonna show you through that today. I got some slides to go through. I do have several demo applications. I don't know if we're gonna get through all of them today or not, but I do have links to. They're all in GitHub, so we'll be able to share those, and you can run them locally and reach out to me anytime if you have any questions on those as well. So without any further ado, let's get going. All right. So AI. ChatGPT, Llama, you name it, Bard, they're all large language models, right? Which basically means they were trained on the internet. And they really have been the big switch, right? I think when ChatGPT hit the world in November of 22, it became the most popular and most quickly adopted platform in the world ever. Why? Because it's so powerful. And all of a sudden, people are trying to think, how do we take advantage of these different things? And as a developer, you quickly realize that going beyond, hey, opening up the ChatGPT window and asking it to summarize something for you, or asking it to, create a report for you from scratch, or don't plagiarize your papers, please. But anyway, as soon as you realize you're trying to integrate that in an application, like, oh, this is not that easy, right? And getting information out of a large language model is harder than you think a lot of times. And we're so used to, as developers, you write code, and you may have to debug it a few times, get it just right, but it works every time, right? Once you get it set, you're good to go, and it's very familiar. That process is very straightforward and very easy to use as you get more seasoned. Now you throw in a large language model, and like, oh, it kind of throws everything on its head. Things kind of become hard, right? And that's where Semantic Kernel here is trying to bridge that gap. And you really start doing quickly, kind of run out of things of what you can do out of the box with the simple APIs, right? Large language models, they were trained with a snapshot of time, right? And anything that happened the day after they were trained, they don't know anything about, right? So that becomes a problem. And we're seeing, right, is that the different model vendors are updating their models more frequently now than they did to begin with. But they're still, as soon as they take that snapshot of information, that next day, the next hour, they're potentially out of date, right? So how do we bridge that gap? It really becomes clear now that you really need new tools, right? And that's where Semantic Kernel comes into play. So what does Semantic Kernel do for you? And why do you need these tools in general, right? Well, when you look at this different features, whether it's a GPT feature or a Llama feature or whatever, pick your large language model, right? They're iterating faster than most products ever dream of, and so as a result, we have API changes, we have all sorts of things changing under the hood, right? Because they're moving so fast. And if you're just using the large language models on their own, right, that's all based on the prompt, right? And we'll talk a little about prompts, and if you've ever interacted with a chatbot for GPT, you know what a prompt is. It's how you ask the questions, what you want to get out of it. And like I said, when the day after the training's done, right, you can't. You can't get any new information out of it. So the idea of how do we mix then these prompting, right? What we call semantic or prompt code with native code, whether that C#, Python, Java, whatever the case may be, right? And this is, again, these are all things. If you haven't figured out yet, right? This is This is what on the left-hand side, the from is this is what you get without semantic kernel, without these tools to help you move along. And obviously semantic kernel is the to, right? You're going to hear you can mix prompts with native code. You have vector memory for fast prompting. We'll go into memory a little bit later, right? You have a common approach, right? And you'll see that when we get into some of the code samples of how you call a prompt plugin versus a native plugin, exactly the same. So it makes it very, very simple. And then also too, really the ability to build and create ready to go prompts across your entire platform. Okay, so again, why semantic kernel? Because really you need to take full advantage of that LLM. And here's the key one: you want to future-proof your code investment, right? How do I protect myself from the very rapidly changing API calls and capabilities of these different tools, while not having to keep going out and learn 20 different things, right? The idea of semantic kernel is it keeps it all together for you. It is that layer between you and that ever-changing surface area of the API calls, and you have a good common way to call things, right? And really what I like to do is kind of go, like I said, kind of move beyond the chatbot. Chatbots are great, right? You see them in Teams, you see them in ChatGPT, and then integrated, all the different Microsoft Copilots, right? Those are all kind of the chat things. You can ask it a question, type it in, and you get a prompt back, and that's great. But you can only go so far when you think about it as an app developer, when you try to figure out how do I add business value to my applications beyond a chat interface, right? Which is a great start. Right? Don't get me wrong, having a good AI chatbot is awesome, but what's that next level? And that's really what I'm going to focus on today, is kind of that next level of how do I become even smarter and integrate AI even deeper into my application beyond that chatbot. Okay. So where does semantic kernel lay? Well, it's really here in this AI orchestration level. Right? You have at the bottom, you have the foundation models, the AI infrastructure, right? That are all taken care of for you, right? You're not building foundational models, and if you are, wow, you must have a really big wallet, right? And then and on top of it is, your copilots, your plugins, your apps, right? All the stuff that you want to leverage. And semantic kernel really is that orchestrator in the middle that helps you manage that, helps you manage not only the interaction with the foundation models, right, but also with, with regular code, right? So from a process flow perspective, now I'm going to guess is kind of going a little deeper, right? Into what is, why do they call it semantic kernel, right? And this may seem I'm going a little too deep without really explaining too much what it is, but I want to kind of give you an overall view of what is it doing for you before we kind of break out each individual piece, right? And here's got the idea of, hey, I got my application, right? And I got my application, which is either a chatbot or something built into my app or whatever the case may be, and I need to get information out of a AI model, right? Now I can do two things, right? And I can have the AI model process something I feed into it, right? From the application itself, or I can actually go and get information from other plugins, which we'll talk about that in a minute. But really what it's doing when your application invokes semantic kernel, right? Semantic kernel is configured with an AI service, right? And the AI service has different models that you're going to use. You're going to render that prompt. So semantic kernel, right? One of the great things it can do for it, and we'll see that in the demo and in the apps, is you can have, like I said in the prior slide, kind of pre-built prompts that work, you've tested, and use those prompts to then invoke the service, right? So it manages all this for you in a simple call from your application. The AI model does its thing, right, with whatever you've asked it to do. And then the kernel can go back and parse that response. So that response, in part, is based on your prompt, right? Hey, you can tell, hey, I want well-formatted JSON, or hey, I want a paragraph, or I want a bolded list, whatever the case may be, right? And then you have the kernel parse that and send the information back. Okay, so again, it's that orchestration in between that if you were to build all of this, right, into your application itself, you're kind of building a one-off kind of standalone isolated application that you really can't share this feature functionality because it's built into your app. So So the idea of semantic kernel is it has this SDK that helps it for you, does all this for you. So now your application can focus on application things, right? And semantic kernel can manage the interaction between that large language model and your app. So it is that, again, that orchestration layer. Okay. So kind of deeper into the process of what it does. So the kernel has this context, right? Starts off with either a question you're asking, which very often is going to require some sort of external information, right? Unless you're asking it about something that it was trained on specifically. So GPT-4, the latest was trained in April of 2023. So if you're asking it for public information prior to that, well, you don't need anything else, right? But if you're asking it about, hey, my internal information for my company, I need to know something more about current events, that type of thing, you're going to need some sort of plugin for that, and potentially some memory. So this memory recall there's memory plugins, but there's also the ability to accept to call native code, which is going to be, which we'll see in some of the other plugins with regards to, hey, I need to go get information from a search engine, or I need to get information from a document repository that I have, and so on. We'll talk about plans in a bit. And the concept of a plan is I have to chain events together. And we're going to go in more detail about that in a bit. And then we also talk about connectors. So one of the really great things about semantic kernel in the Microsoft ecosphere, right, is built-in connectors to the Graph API. So if you never used the Graph API before, if you're in the Microsoft ecosystem of Microsoft Office and Exchange and Outlook Online, or whatever, Azure basically, right, and all that, there's a ton of information, right, that with regards to, hey, I need to get information from my calendar or from my email or from Teams. I need to ask questions about things across SharePoint. And you want this built into your application. There's that Graph API that you can use to call that. And then the semantic functions or prompt functions, we kind of use those interchangeably. That's hey, this is the question you're going to ask the large language model, and the native function is going to be a plugin, hey, just to do math, for instance, right? There's a built-in plugin for math. Like, why do I need a plugin for math? Large language models don't do math. Just don't ask, ChatGPT to add 2 + 2. It won't always give you 4. That's not what they're trained on. That's not what they're good at. So that's where, hey, maybe you have a native function to do something, to do a concrete in and out type thing. Okay. So that's kind of the pipeline of how it all works. So native versus semantic function, right? So native function is your code that you need to go, and whether it's saving information, right? You're sending information to through your application that you want the LLM to look over, and I need to save it and recall it later. That would be a native function, right? Large language models can't do that. You need to look something up, whether it's off the internet or internally or something from a document or whatever. That, again, is something a native function would do. And again, a native function is code, right? So, and we'll see about attributions, like my examples will be in C#. Semantic kernel also has a Python and Java implementations. They're all very similar. But what you can do is you can tell semantic kernel, hey, these methods in my .NET application, I want you to register them as native functions. Therefore, I can call them as native, call them through that same pipeline that we just showed, right? And then perform any actions. So I need to save something to a database. I need to look something up from a database. I need to save a file. I need to respond an HTTP response back to a user in a particular format. These are all things that native functions do, right? Now, semantic functions, that's all about that prompting, taking that prompt along with any information that you may have looked up, sending it to the model to process that request. Summarize. I need to extract information from this or whatever, and then get that response back. So that's the concept between semantic and non-semantic functions. Okay. So then we have the concept of planners. Okay. So I kind of teased this already before, is what happens if you need to string calls together. I need to look something up and then send that information to the large language model. And then I need to take that information back from the large language model and then do something else with it, maybe save it or something else. And then I need to take that and send a response back to the user. Well, as we'll see in one of the demos, right, that I have, is you can do that. You can manually string them together. But what's really cool is you can also ask Semantic Kernel, hey, here are all the functions I have available. Here's what I want to do. You figure out the best way to do it with the functions that I have, right? And it will figure out for you, oh, in order to achieve this goal, I need to string together this function, then this one, then this one, then this one, and there's the output, right? Which is really, really great when you're in this kind of non-deterministic world of, I don't really necessarily know what the ask is going to be, or the intent of the user might change based on the application, right? So I don't necessarily know exactly how things are going to flow. Using a planner to help you figure out how to best solve a problem is really, really spectacular. And we'll see that as well. Okay. All right. So I want to kind of show you the money slide here. This has got everything in it. Again, not to confuse you. These will be available, by the way, right? So there's a lot on some of these slides. From the first flow slide, and certainly this one, there's a lot of different things in here. But kind of want to show you the full ecosystem of Semantic Kernel, right? So we have the kernel itself, right, in which which is that orchestrator, right? That orchestrator that says, hey, what are all the things I can do? And let's go ahead and do them, and then feedback to the user, right? Semantic Kernel, I can define my functions, my plans, my prompt engineering, OpenAI support. I have my skills or plugins, right? And these plugins or skills, we talked about those semantic functions and native functions, right? So native function example, right? I talked, hey, what time is it? If you ever want to have fun, go ask ChatGPT what time it is or what day it is. You get some really fun answers. I need to, call SQL. I need to do some I/O. I need to do some local services, right? I need to go look at some information that is not trained on or anything, and I need to go call APIs to do that. There's this memory store, which is interaction. Both of these types of functions have access to. We're seeing an example of Azure Cognitive Search, where we just renamed it to AI Search. But there's a ton of different storage mechanisms you can do. So Azure AI Search and Cosmos DB are two really big ones in the Microsoft world, but obviously we have Postgres and Redis and a bunch of different potential memory stores. On the semantic function side, right, we actually have OpenAI, Azure OpenAI, Hugging Face, Llama, all the different models. The new one seems to come out just about every other day. But the idea is with the semantic kernel, you can swap them out seamlessly, right? Just through basically configuration. Say, hey, I want to call Azure OpenAI, or I call OpenAI directly, and then maybe I want to switch models too. I want to use GPT-3.5 or GPT-4 or GPT-4 Turbo, whatever the case may be, right? You can do that very simply with configuration and not have to worry about changing your code, which honestly is spectacular, because when I started working with Semantic Kernel and the team about a year ago, that the models have changed, and literally my code doesn't have to change. I just have to go ahead and change the targeting model. So it's really spectacular. Okay, so I've given you everybody the very large view of things. I'm going to take a quick look before I dump into demos. If we have any, no. So as Tom mentioned, you should have the Q&A available at the top bar. If you have any questions along the way, feel free to put them in there. Try to keep an eye out for those and answer them if I can in line. But other than that, I think it is demo time. Okay. So as I mentioned before, I kind of want to stay away from the concept of a chatbot, right? Chatbots are everywhere. You can find chatbot examples are kind of a dime a dozen. What I want to show you here is an application that is truly 100% AI driven, and we'll walk through that in a bit. But the concept of this app, right, is, hey, I want to, by just giving a company name, I want to produce an executive summary for a meeting prep. So think of it, your CEO is going to go meet with the CEO of another company, and on a particular topic, you want to produce some prep notes for your CEO, right? So I'm going to say, okay, well, so I'm going to get this started. And then get that moving, and then kind of show you what this guy is doing. So in this application, it's getting, so I did the call that I did prior, just to keep it moving along, is I put in Microsoft's name, I said, hey, and it's calling this get company executives. But before I go there, I want to kind of show you how I initialized Semantic Kernel. Right. So what we have here, we have my AI configuration, right, which is basically just saying, hey, I need to know for Azure OpenAI the deployment name, endpoint, API key, and model name that I want to use, right? It's in my config file, right? So all it is in Azure, I have an instance of Azure OpenAI. I have a particular deployment name and model name that I have ready to use, and then the endpoint API key. Pretty straightforward. Okay. Now, this next step here, right? This is where I am. Let's see, maybe it's a little bigger for you so we can see it. What we have here is adding a plugin. So you can kind of see I have this web search engine plugin, which is a built-in item for Semantic Kernel. And I'm basically, hey, go ahead and import that and call it web search engine. So what I've done here, if we think back a couple minutes ago to the slides, I've registered a native function with Semantic Kernel. Right. So I'm just saying, hey, I want to be able to do a web search from Semantic Kernel. So that's step number one. Okay. Now what I'm doing here, in this next bit here, is now I am now collecting prompts from YAML. Okay. So there are a couple ways to store prompts in Azure OpenAI. In Semantic Kernel, sorry. The newest one, which was kind of just released with Semantic Kernel 1.0, the first full release, just last year, late last year, is through YAML. Let me show you what that looks like. The other one is through a JSON and a text file, which I'll show you that as well. But you kind of see, it's pretty straightforward. We have a name, right? So I'm going to call it, and the description. Now, the description is incredibly important, right? This guy right here, this description is what, when you're talking about a planner, is what the model is going to use to figure out what does this function do. Therefore, when I'm trying to figure out from a plan perspective of how I need to stitch things together, it's going to use that description to say, oh, this is what this guy does. Therefore, I can use him to execute what I want it to do. This next bit here, the template, right? This is basically the prompt. So there's a couple interesting things here. One is this message role, right? This is basically telling the large language model, this is your bit, right? This is what I want you to do, okay? Which is, hey, basically here's the prompt. I'm giving it basic information, right? For this company name and executive name, which are the input variables, right? So kind of see down here, I got some input variables, company name, executive name. Go ahead and get some reference links, give me a biography on these people. And then, oh, by the way, return it as valid JSON. So that's when I talk about, hey, parsing it out. Why did I ask for valid JSON? Because it's programmatically, it's real easy to parse JSON, and that's what I want back end. So you can tell it, hey, this is how I want it back. And then these two down here, I apologize for the color coding. Visual Studio isn't quite right because it's got this, thinking this colon is actually part of the YAML, which is not. But way down here, we have a role for the user, right, which is the person info that I'm sending in. And then the system role, this last one is, hey, this is your response. So really what you're doing, and you almost think about when you look at large language models, someone told me this a while ago, and I thought it was a great example of large language models. Think of them as having the knowledge of the internet in the mind of a 2-year-old. Right? You need to be very specific in what your ask is and what you want it to do, how you want it back. And if you're very detailed and very specific, it's going to do it awesome. If you're kind of not very specific on loosey-goosey, just like a toddler's going to like go and do some weird things, right? LLMs will do the same thing. So you want to be very specific in what you're going to do. Like for instance, like I have this example here, right? It says only return, oops, wrong one. Only return valid JSON that can be directly serialized as a C# object, right? This seems like oddly specific, right? But at the same time, I needed to do that because sometimes it was giving me JSON with extra comments and stuff on it. Like, I don't want that. So I just kind of told, hey, this is exactly what I want you to do. Okay. And there's some execution settings, right? So this is kind of how I want to call the LLM. So max tokens. So tokens are approximately 4 letters. It's just a way of measuring input and output into a large language model. So I can tell with Semantic Kernel, hey, I don't want you to use more than 1,000 tokens. And that's a way to kind of put a box around your prompt to say, hey, I don't want you to return me a book. You know, it's got to be, I want to keep it short and simple. And you can also do, there's your default, but it can do, based on the model type, right? You can have, if I had more different models available to me, you can have in this one YAML prompt, right? You can define how you want it to interact, Semantic Kernel interact based on the type of model that you're using. So it's kind of cool. You can have a GPT-4, you can have GPT-3.5 Turbo, you can have Llama, or you can have Hugging Face. All these different models, and you can have different things in there. So for instance, like if you're using the original ChatGPT-4, which has a lower token count than GPT-32K, if you had a higher token than the original GPT-4 could take, it would give you an error. But you can now with this YAML configuration say, hey, if I'm using GPT-4, I want to add this max token, and GPT-4 32K. I want to have this max token, right, to give it expandable. So, so that's kind of cool on how you can manage the different plugins or different functions, I should say, right? So to go back over here, I'm basically loading up all those as functions. Now you kind of see what I'm doing down here. Get the company executives. I am running through them. I'm going through, and this is a very manual. We'll look at planners in another demo in a minute. You can kind of see I'm first running. Okay, I'm going to run that. I'm going to run that data function, get Bing results, right? And then I'm going to paragraph it. So paragraphing. So you can kind of think the Bing results is going to go out and do a web search, right? Based on this prompt, based on this query, right? If you were to type this into Bing, this is basically what it's doing. It's doing through the API. It's going to give me a list of results, and it's going to give you. Oh, sorry, this and that. But if it can give you paragraphs, the reason it gives you paragraphs, you want to break up a huge document again because of that token limit I already talked about. So, right, so you give it a token limit, and this there's a function inside Semantic Kernel which says, okay, it's going to break out this very large thing into a bunch of smaller ones that I can then feed into the model via bite-sized pieces, right? Now here I'm calling my YAML prompt. So I'm picking my YAML prompts here based on that name. So again, I'm doing it very, very, very manually. I have that function. I'm going to call that function with the 2 inputs that it needs. And you'll see a bunch of tasking and multi-threading here and so on. But you kind of get the idea. Is that I have, and the reason I do that is because on the app, just should go back over here now. I only picked one person, but I could pick a bunch, right? And if you notice one thing, if you're working with large language models, they're not the fastest things in the world. When you think about expected response times for the internet, right? Hey, a 2-second load time on a page is forever. But when you ask LLM to give me some information, there's a reason, like the ChatGPT, it streams the response back, because if you waited for it to finish, you'd probably take a nap, right? So why did I do all this multi-threading and tasking? Well, because I'm asking a lot of the LLM, so I'm going to multi-thread it out and ask it a lot of questions at the same time, right? So you can kind of see what this guy did is as you remember, I had first the list of executives, which I did by putting in Microsoft here, and the LLM went out using that Bing connector or function, I should say, went out and got me some articles. They then fed that into the large language model, say, hey, go extract the executives out of these documents. So it did that. That was that list that we started with. Then I picked Satya Nadella, and then I said, okay, based on this, go find me information about this person. So again, it did another web search specifically for Satya Nadella, took those articles, first did it, summarized it for me, summarized his bio, right? And then extracted his business priorities based off of all those. And here are all the references that it used, right? So all that information was simply done through the LLM and the prompting. So the executive list, that's what I started off with. Executive bios, right? That was the one we already looked at. Executive priorities, hey, give me a bulleted list of priorities. So again, if you look at these YAML files, they're all basically, they're all the same format. What's really changing in here, for the meat of it, is the description and the template, right? And then it also went out and said, okay, I need to get the quarterly results for this particular company. So then again, did another search out to the internet to go get the results, and then I don't know if you ever looked at quarterly results for a company. They're really long and very confusing, and I would never want to read them unless I'm going to bed and I need something to put me to sleep. Summarize quarterly results, right? Which is pretty cool. So when you say FY24 Q1, that was our last quarterly results that we released, right? So pretty interesting. And then I'm not sure what happened here, but I asked it when I put in a meeting topic of Azure OpenAI, I asked it to then go out, find me three interesting articles about Microsoft on this topic, and summarize them for me. Right, so again, all AI did all of this. There's the links to me when you want to read them a little more. But I want to, the focus and the purpose of this application, right? It's an interesting demo. It's kind of cool. But at the same time, it is completely AI driven, right? There's no parsing of documents on my own. There's no extracting of information. There's no searching for names. There's no regular expressions. It's strictly, I start with the company name. That's the only input I had. Other than that, checking a box. And then if I'm interested in an article, that's it. The application itself, with those few prompts, a little bit of information, went out and got all that information for me, got me that list, created biographies, created priorities, or extracted priorities, and gave me lists of all these different things. So when you look at that, it's really talking about, again, how do I get beyond the chatbot? How do I get real business value out of AI? Here's some key ones. I mean, this is a really great one where you look at, okay, how do I extract information? This is extracting information off of web searches and things I can find on the internet. But think if you could take that same thing and look at across maybe documents you're getting from your customers, right? Which we'll actually look at in a little bit. Or information that you have, in repositories somewhere, or all this. The kind of the I find my limiting factor when thinking about how to interact with an AI is my own imagination, to be brutally honest, right? It's really about how do I use these things, and once you can kind of get past that concept of, oh yeah, an AI can probably do it, that really kind of opens the door. That was my biggest thing working with AIs, is assume that it can do what you want it to do, right? Until maybe it's demonstrated that it can't. But I have yet to be disappointed on things that it can, things that it can't do. Okay. Okay, so that was demo number one. All right, so I'm going to go back to this question: how semantic kernel is similar or different from prompt flow? So semantic kernel is really all about kind of coding inside your application. It's that orchestrator bit in between. And prompt flow, to me, the biggest cool feature of prompt flow is the ability to take prompts and run them and basically explore them. Right, I want to give me 500 variations of an input to a prompt. I want to see how they respond, and I want to get accuracy percentages off of that to really fine tune my prompt. It is more than that, right? And there you can take that as part of an application and start stringing it together. It is right now only Python, whereas Semantic Kernel is C#, Python, and Java. But that's kind of where I see them play. But an interesting piece too is I'm going to go over this. Oh, back over to the YAML format that they have here. This is the exact same YAML format that Promptflow uses. And they did that on purpose, as you might imagine. Right, so you can actually take Promptflow YAML prompts like this that you fine tune and then throw them and use those as a library for Semantic Kernel. Right, it's kind of cool. Okay, so I'm gonna switch over, different demo, right? Others and a couple key things I want to show in this particular one, right? Let's explore that concept of a planner. So this demo is an API demo that you ask it an interesting question. So for instance, this is, what are the 3 most common issues? I'm going to send that over and come back over to in a second. This is actually using Azure Fabric under the hood, which this is not an Azure Fabric talk, but it's Azure Fabric is a concept of taking data from different systems and exposing them in a very similar format, basically exposing whether it's documents or data, structured, unstructured data in Azure or literally anywhere, any cloud, any on-prem, whatever, and exposing them as a single interface without having to move it either, which is kind of cool. But anyway, basically there's data inside a bunch of tables inside Azure Fabric, and I need to understand information about those things. I need to basically ask questions to about it. And it really does it. And this is a stepwise execution, right? Hey, first thing it's going to do is going to get this prompt, which if you recall was this prompt here. What are the 3 most common issues? It's going to run a query creator, which is going to create a SQL query based on the input. And this, by the way, is another way you can define prompts in Semantic Kernel. It's this combination of a config.json and an SK prompt text file. It's going to look very, very familiar, right? It has a description, wrong direction, has a description, has the tokens, right? And then on this side, I got it's a text prompt itself, right? So what they did is the YAML kind of combines these two, right, which then makes it easier, makes it more portable. Like it's the same kind of format you'd use in Promptflow. The YAML format is fairly new to Semantic Kernel, just got released with version 1. I'm really starting to switch everything over to YAML. Just easier. I should honestly just kind of have everything in one file. So that's pretty straightforward. So then so query creator, which is a semantic prompt, right? So it's a semantic or prompt thing. It's going to actually go and ask the AI for that. Then you can see the next one is a native prompt or native connector or plugin where it's going to go actually query the database. Then it's going to go and talk to the LLM again, and then it's going to go and create an adaptive card. Adaptive card is a JSON format that Teams uses, and so that way, ideally, you can think about this being a way to get information back to get it back into Teams. So you can kind of see, just looking at this, I got 4 different calls, all invoke async, all very similar format. You can't tell by looking at it which one's a native function and which one is a prompt function, right? You just can't, and that's by design, right? Because if you look at my data connector here, this is the first time we're going to see what a native function looks like. So we have this description, which again should be familiar, right? There were descriptions in the prompt functions. for both the kernel, the function itself, right? What does this function do, right? And then the particular attributes into it as well. So exact same things we found in the prompt functions. We see attributed in C# here as the descriptions for these guys in the native function, which means then, right, that as you register them with the kernel, it knows how to use them. So let me go ahead and switch over to Planner. Oops, I should probably stop working first. So what does this guy look like then from a Planner perspective? Oh, messing with me here. Come on, you can do it. Well, let's try this again. Okay, there we go. Oh. Hey, looks like it's going to be, there we go. Okay. All right. So from a Planner perspective, now you saw in the last version of this code, right, I made 4 consecutive calls. In this version of the code, which by the way also has go back to the YAML prompt as well. This guy, I'm doing, okay, I have a goal now. Instead of having this each one do its own thing, I have a goal, which is, hey, I want to infer the user's request and get information from the database and such and so forth. And then I take that goal and I create a plan for it. What's this plan all about? This plan is sending a request to a large language model with the list of all the functions, again, using the description, right? That's available in all of them, to have the LLM say, hey, okay, here's my goal. Here are all the things I can do. How do I stitch them together, right, to achieve the goal, right? That's essentially what you're asking the large language model to do, is figure out that plan, okay? And assuming this guy built properly, here, run it. So what it's going to do is going to create that plan, and it's going to go and execute it for me. So you can kind of see the code is a lot easier, right? Say, I'm just creating the plan and I'm invoking it. I got a couple logging things in here. But it's really kind of interesting in that you're allowing now, pull over the output here, so you can kind of see it's creating a plan, right? And now creating this plan is a call to the large language model, right? So this is important to understand. And you kind of see the plan that it created here are the steps. So query creator, get the database, derive insights, create an adaptive card, and then return it with the, return this stuff. So you can kind of see that in this particular example, the large language model planner, in essence, did the exact same thing I did stepwise, right? But the correct advantage of it, right, is, of course, is that it's dynamic. I don't necessarily know in this particular example, right? Yeah, I know exactly what I want to do, but it allows me then to dynamically create that plan. Another interesting thing too is that you saw that plan was in this JSON format. You can, if you want, instead of have it create that plan every time, and instead of calling the function sequentially, right, the 2 different examples we saw, you can actually take that plan, save it off, right, and then load it as a plan. So what it looks like in the code then would be, instead of create plan, say load the plan from a file and then execute it. Saves you a call to the large language model to figure out the plan, right? It's obviously not dynamic because you're reading it from a text file, but from a code perspective, right? Hey, I have this known plan because this is a very deterministic path for my code for the particular intent. I can just go ahead and grab that plan template and execute it that way, right? So there's a lot of flexibility in that concept. Another way to do it, this exact same thing, right? And this is called function calling. So something that GPT OpenAI came out with toward the end of last year is this concept of function calling, right? Having the AI call things sequentially for you. It's a little bit different from Planner. It's nuanced, right? And the advantage of the function calling, right, is if there's a concept of functions available, you can register your own function with OpenAI. It becomes an API endpoint for OpenAI, right? So we have the ability to interact with those as well with this function calling. But you kind of see the idea is pretty similar, right? It's still a planner, right? In this case, it's the function stepwise calling planner. There's still, if you will, a kind of a goal, right? Which is the particular, in this case, is the question for the input. And then it goes and executes it and gets you the result. Now, the really cool thing about this, the difference between planners and functions is functions have the ability to call themselves recursively. All right, so you can kind of see there's this concept of, let me go ahead and start this real quick. There's this concept of final answer, right? Why is it called final answer? Because depending on your prompt, depending on the function they have available, they may be able to recursively call each other and continually refine the output until it provides a final result, right? Which, if you think about it, is pretty darn cool. So let me go ahead and do the results here. So before we saw I had that JSON template here. Now this is the function call that it's doing. It's invoking this generate plan. It generated the plan, and here is the plan that's going to call right here. Oops. All right. Right here. So we got the arguments, which is all the different pieces I put in. These are all available functions, right, that have available to it. Here's the goal, right, and here's what it's going to do. So again, if you look at it, very, very similar. It's going to database creator, database, insights, adaptive card, send the final answer. So you can kind of see in each different way I've done it, it's resulted in the same thing. Why would you pick one or the other? Right. Well, if you're very deterministic, you can certainly call them sequentially. Nothing wrong with that. Right. And it's really cool. So we demonstrated it interacts seamlessly between native functions, calling code, getting information from a database, creating a adaptive card, as well as calling out to large language model. Right. Which, hey, go create a query for me based on the information that you have. Go ahead and summarize this information for me, or derive insights, right? Like, you'll see there's a lot of derived insights in the LLM world, right? There's that in the adaptive card bit. So we kind of see this query creator. It's going to show you, examine what this prompt looks like a little bit, because I think it's interesting. Is, again, there's the description, right? What do you want to do? What we've done here with this guy is we've told it, here are the tables. Here's the table definition. So based on the question you have, create a T-SQL statement. Here are the tables that are available, right? And there's some additional instructions, right? It's interesting because one of the tables that we have is actually misspelled. Accessibility here is misspelled, ironically. And so I had to tell it to only use a table name spelling exactly, because it was actually trying to be smart enough and change my spelling for me, which I thought was hilarious. So it actually was able to create that SQL statement based on this. We're trying to estimate how long it would take to do that by hand, like how code-wise, how would you be able to figure that out? And we decided it was just near impossible to do that, right? But the LLM does it in seconds, which is pretty cool. So 3 different methods: call directly, use the planner, use function calling. Planner, so stepwise, if it's very deterministic. Planner dynamically, right? If you have a set of functions that you don't need kind of any refinement for, but hey, these are the things they're going to do. If I call them sequentially without any recursion, it's going to give me the exact result. Then certainly using planner is awesome, actually. And then you can even save that plan off, right? Which kind of is that middle ground between a dynamic planner and a stepwise function calling. And then there's this, or stepwise, function calling. And then there's the GPT function caller. Why would you use that? Well, first of all, you can't save the function plan, right? Like you can with the other planner. But it does allow for that recursive calling of functions, that refinement, right? So depending on your use case, it's kind of how you would choose to use them. I've already mentioned, right, this concept of the YAML, prompts. I would just go, if you're new to Semantic Kernel, I'd go straight to these. I think they're going to be the future. I think they're going to be more reusable. And then, one thing I really didn't talk much about is the concept of, now that if you kind of see this template, right? I did a lot of refinement on this. I can now reuse this prompt, right? So I can share this prompt with other people. I can create a library of prompts that are available for people to use. So nobody has to go through this, because prompting, in the same way as native coding, right? You go through, you write it, you debug it, you go back and forth. You're going to do the same thing with prompts. It's going to have a lot of refinement to be very, very specific at exactly what you want out of it. And once you've done that work, you want to make, all right, cool. Now I don't do this again. I'm going to share it, right? Semantic Kernel makes that incredibly, incredibly easy for you to do. All right. We are at the 5-minute mark here. Yes, so you talk about RAG implementations, the last, yeah, actually, I actually have a demo for RAG implementation. I'm not going to have time to go through it. You will have links to all my GitHub, and all these are, except for the app one. These last two are fully deployable into Azure. This one here, which is document questions function, is total RAG using OpenAI and semantic memory, which we didn't get too much into, but it's concept of saving your information into Azure AI search, and asking questions on it. All right, so I can just here, let's go real quick, 2 seconds, ask it a question. So I have 2 documents in my AI search. I'm asking, hey, what are the dates associated with these documents? All right, and it says running. Yep, okay, good. So one of the documents is the Declaration of Independence of the United States, dated 1776. And the other one actually is a document I gave to my pet sitter on how to take care of my dog and my cat, which was dated December 8th. Right. So you can think about that and look at how do I get information out of documents that I have stored somewhere, load them into semantic memory, and then go ahead and just ask questions over them, right? So you can think about if I get a non-standard format from a customer and I want to get specific information out of it, load in semantic memory, ask the questions, whether in this way through API or through a standard implementation of your application, and let the AI extract it for you. It's really spectacular. All right. So given that, let me go back to my slides in the last 3 minutes. And so like I said, all these are available on GitHub. So they're all public repositories. I encourage everybody, if you're interested in looking at them, go and take a look at them. These last, they all have different branches. So if you take a look at the different branches, hopefully they're named properly. You can kind of switch through like I did with the YAML planner and the function calling or the straight calling, right? All available. My GitHub name is M. McKechnie. So if you want to follow me or got any questions or anything about any of these repositories, 100% feel free to reach out. And then kind of the take home here is really all about, hey, look at using Semantic Kernel as a really straightforward way to get started automating your business processes, getting value right out of information that's already there, but just it's kind of tied up and hard to use and hard to get at, or very intensive to get at. These AI models are really good at it. It's one of the things they're very specialized to do, and Semantic Kernel makes it super easy to get into that. A couple of links for Semantic Kernel on its own, right? Semantic Kernel Home, these are the Microsoft documentation. They do have a Discord channel. If you join the Discord channel, they actually have office hours now, once a month, general office hours, and then they also have a Python and a Java user group every other week. So definitely join the Discord channel. They have meetings available. It's the product group that has those. And they have a blog too, which they seem to be posting about once a week or so. with new interesting enhancements. They're moving as fast as the AI models are moving. So it's always interested to, something to keep up on. I'm subscribed to those as well myself. And last but not least, right? Anybody's interested in a workshop, a hackathon, ideation session. Like I said, the hardest concept with getting started with AI is, your imagination. Lots of different ways to kind of get the juices flowing, get people thinking about it. Absolutely, 100% feel free to reach out. So yes, how do we get some just last 2 seconds here? Yes, they're all on GitHub. Yes, this recording will be available later. What else we got? Is there a planner for creating queries using questions that the RAG one? I think I got most of them. Was that Tom? Sorry.
No, I said I think you've addressed all of them. I've been monitoring here. Great presentation, Mike. We are at time. Yep. Thank you so much, everyone, for attending. And Mike, thank you for a very insightful presentation. I know I always learn whenever I hear you share these topics. So, and do keep an eye out. You mentioned Fabric. We do have a session that we're still planning that's going to be on 2 weeks' time to kind of maybe get you caught up to speed on that topic. But again, thank you so much for presenting, and we'll talk to you guys soon. Thank you much.
Thanks, everybody.